Hi everybody. Today we are solving systems using substitution. On Monday we were solving using graphing, and today we're doing that second method, substitution. So our essential question is, what's the advantage of solving by substitution versus graphing? I hope to include some examples that'll kind of give you some reasons why substitution can be a better method than graphing in some cases. Okay, here's our first equation. And you'll notice with substitution, for the system to be ready to go, you need to have at least one of the equations already solved for a variable. If you look at the red equation, you'll see that x is by itself on one side of the equal side, all by itself, so x equals. That means it's ready to go. So let's write these equations side by side. Oops. We have x plus y equals 600, and we have x equals y plus 200. So we're going to use the equation that has the variable by itself, the one here over on the right. We're going to circle what x is equal to. It's equal to y plus 200. And we're going to take this amount and bring it over to the other equation and substitute it in for x. So x is going to be gone. In its place, we're putting y plus 200, but we still have to have the plus y that's still left on that left-hand side, and then equals 600. Take a quick check and look. Do you have just one type of variable in your equation now? And it looks like we have all y's, so we're good to go. All right, so we're going to combine our like terms. So 1y plus another y makes 2y plus the 200 equals 600. Next, we'll subtract 200. So you get 2y equals 400. And last, divide by 2. And you get y equals 200. So let's start setting up our solution. Remember, our solution is a coordinate. It's the place where the lines would cross if we had graphed it. So our y coordinate is 200. Now go back to the other equation, the one you haven't used yet, the one that says x equals, and we're going to find the value of x. Since we already know what y is, we can replace y in this equation with 200. So we get x equals 200 plus 200. So we have x equals 400. So our answer is 400, 200. So here's one example why using substitution can be easier than using graphing, because you would have to have a huge coordinate plane in order to set this up, to do the graphing for this, and it wouldn't really be practical. So sometimes your numbers are just too large to make it using a graph very practical. So there's one part of your answer for your essential question. Sometimes the numbers are just too big. You need another method other than graphing. Okay, here's our next one. If we look here, the blue equation this time has a variable by itself. Remember, it could be x or it could be y. This time it's x again. As long as you have one equation where a variable is alone on one side of the equal sign, then you are ready to go with substitution. Set your equations up side by side. So I'm going to rewrite it. X equals 4x plus 3. And the second one, 2y plus x equals 6. So I'm going to that left-hand equation, and we're going to circle what x is equal to, 4y plus 3. And I'm going to bring it over to the other equation and substitute it in for x. Okay, so I'm keeping the 2y, and in place of x, I'm putting positive 4y plus 3. And then I have my equals and my 6. Now combine the like terms. 2y plus 4y gives us 6y plus 3 equals 6. Next, I'm going to subtract 3. We get, oops, that's not there. No, let's erase that. Sorry, a little stray mark there. Don't want you to think it's an equal sign. Okay, we get 6y equals 3. And then our last step is to divide by 6. So we get y equals, no, not 2, 1/2. Right, divide the top and the bottom by 3. That gives you 1/2. Okay, let's take that 1/2. That's part of our answer. Remember, we're looking for a coordinate, so we just found out the y coordinate is 1/2. Let's go substitute 1/2 into the other equation. So we get x is equal to 4 times 1/2 plus 3. So we have to do the multiplication first. I'm going to put 4 over 1. So 4 times 1 is 4. 1 times 2 is 2, plus the 3. So 4 over 2, that's just 2. 2 plus 3, that makes 5. So I get 5 1/2. Here's another reason to use a method other than graphing. Sometimes you get fraction answers. It's really hard to tell what your fraction answers are if you are graphing. It's just way too difficult to tell. Is it a half? Is it a third? Is it a fourth? You're just kind of guessing if you're using unit graph paper. So there's another reason. You can be more accurate when you are using substitution method if your answers don't come out to whole numbers. Okay. Here's just one more example. Again, we've got a variable that's by itself in the blue equation. We've got y by itself this time. Y equals 2x minus 5. So let's set this up side by side. And y is equal to 2x minus 5, so we're going to circle that. And we're going to bring it over and substitute it in for the y. Okay, so 3 is in front of the y. That means 3 times y. That means it has to be 3 times whatever we substitute for y. So put your parentheses so we can go ahead and make sure that 3 multiplies everything inside. 3 gets distributed to this whole amount. And then you still have a minus x, and an equals, and a 5. Let's distribute the 3. 3 times 2x gives us 6x. 3 times negative 5 gives us negative 15. Minus x equals 5. Combine your like terms. 6x minus x gives us 5x. Minus 15 equals 5. Add 15 to both sides. Oops. We get 5x equals 20. Last step, divide by 5. We get x equals 4. So when we start to set up our solution, our x coordinate is 4. We still need to go back and find the y coordinate by using the other equation. So y equals 2 times, we know now the x value is 4, minus 5. So y equals 8 minus 5, or y equals 3. So that one is 4, 3. Don't forget about other situations you can have. This is just a quick reminder. I think you'll recognize these right away. So here we have the x alone. 10 minus 2y is what x is equal to. We bring that to the other equation. Plug it in here. There's a 2 in front, so it's going to be 2 times the x quantity. So 2 times 10 minus 2y plus 4y equals 10. Distribute the 2. 2 times 10 is 20. 2 times negative 2y is negative 4y plus 4y equals 10. Combine your like terms. And this one comes to an early end. We've got 20 equals 10. Okay, remember what's going on here? When the variable is completely gone, and then ask yourself, are you left with a true statement? Is 20 equal to 10? The answer is no, so this would be no solution. And finally, a similar one. Oops. Okay, the y is alone in this one. Y is equal to 3x plus 4. Let's take it to the other equation and plug it in for y. We keep our negative 12x. We keep our plus 4, and then we put parentheses. So 4 multiplies what we replace y with. Replace y with 3x plus 4. Close the parentheses, equals 16. So keep our negative 12x. Distribute the 4. you get plus 12x plus 16 equals 16. Combine your like terms, and you get those cancel out, you get 16 equals 16. Again, variable's gone, another one of those weird situations. Take a look at what you have left. Is 16 equal to 16? The answer is yes, and that means you have infinitely many solutions. Okay, remember that? All right, you have a couple practice problems to do tonight or this afternoon. Go ahead and turn those into Google Classroom when you're done. And don't forget to answer your EQ.